So in this video, I want to speak about obtaining the equation of a perpendicular bisector. Okay, no, I don't like the thickness of that line. Let me freehand this. So let's say I have a line, let's call here A, let's call here B. Let's say here, this point here is the coordinate 1, 3, and here is the coordinate 5, 10. Now, a perpendicular bisector is a line that intersects any line, in this case is the line AB, at the midpoint and is perpendicular to the line AB. So let's call this CD. Now, to find the equation of this perpendicular bisector, we need first the midpoint of this line and, well, the gradient of the line AB. So let's find the gradient of AB. So m of AB is, recall, we have y2 minus y1 all over x2 minus x1. So here would be x1, y1, here would be x2, y2. So we have 10 minus 3 divided by 5 minus 1. This would be 7 over 4. So the gradient of the line AB is 7 over 4. So there's a property where lines are perpendicular, the product of the gradients must be equals to minus 1. So let's denote this gradient by m1. So m1. So the gradient of the line AB is m1, which is 7 on 4. So we have m1, that's another m1 by, let's call the gradient of CD m2. It must be equals to minus 1. So 7 on 4 by minus 4 on 7 would give you minus 1. Now, our next way to obtain the gradient of a line that is perpendicular, you just take the reciprocal and put a negative sign, but I just went a little deeper into the explanation here. So the gradient of the line CD, so CD m would be equals to minus 4 on 7. Now we need to find the midpoint of the line AB because that's where the perpendicular bisector intersects the line. Perpendicular, the 90-degree, bisector bisects. So the midpoint of the line AB, midpoint of AB is given by x1 plus x2 all over 2, y1 plus y2 all over 2. So I'm just doing this on top here. So the midpoint is x1 plus x2 is 1 plus 5, which is 6. 6 divided by 2 is 3. So the midpoint The x coordinate of the midpoint is x1 plus x2, which is 5 plus 1 divided by 2. 6 divided by 2 is 3. And for the y coordinate of the midpoint, we would get 3 plus 10, which is 13. 13 divided by 2 is 6.5. So the reason why we find the coordinates of the midpoint is because to find the equation of the perpendicular bisector, it comes like we finding the equation of a line, and to find the equation of a line, we need a coordinate on the line, which in this case happens to be the midpoint of intersection over here, and the gradient. So that's why we find the midpoint. So the midpoint is given by 3 and 6.5. So this is the coordinate. So just making some space. So for the line CD, or the perpendicular bisector CD, we have the gradient M2 being equals to minus 4 on 7. That's minus 4 on 7. And we have the midpoint being equals to 3 and 6.5. So recall, to obtain the equation of a line, knowing a gradient and a coordinate on the line, we use the following formula. Y minus y1 equals m into x minus x1. M is the gradient. M2 in this case signifies the gradient in this formula. So we have y minus 6.5, here's x1, here's y1, equals to minus 4 on 7, open bracket x minus 3. So we have y minus 6.5 equals to minus 4 on 7x plus 12 on 7. And we need to carry this across, so we would get y is equals to minus 4 on 7x plus 12 on 7 plus 6.5. Now we can neaten this up here, but I don't have my calculator on now, so this could do. So this is the equation of the perpendicular bisector CD. Done. This is the symbol for done in mathematics, a little square. Sometimes you would see Q, E, D. It's Latin for quod erat demonstratum. I might be mispronouncing that, but it's close enough.